Everybody looks sleepy. Me too. You got your notebook? Okay. Got your notebooks? So just before you start, what I want to do this morning is just talk a little bit about what you need to do for the lab report as you're writing it. So first we'll just have a look at the requirements. Okay, so these will be requirements for your lab reports. So even before I say that, I'll just say what the marking is. So you have 3 things altogether, as you know. You have the logbook, which I gave you last time. And then this logbook has 3 labs in it. Lab 1, 2 and 3. Then also with the logbook, you must pick one of these. You don't really have a choice, I'm telling you, to pick the electricity one. And then you have to type this up. This is called coursework 1. And coursework 2 is just a type of lab 4. So no notes for that one, and that's coursework 2. This is worth 10%, and this is worth 10%. Yeah. In fact, this is only worth 2%, and the typing, I think, is 8%. So really, this is really, really, really important, because that's as much as your end of semester 1 exam. Hey, come on.
What exam?
No. What happened to you? Why are you late?
Ask bus driver.
Okay.
I 122.
Yes. If you leave your home sooner, you can be on time.
No.
So, as I was saying, this coursework 2, I have to repeat myself for Amanda and Grace. So, your logbook plus the typed report for coursework 3, that makes 10%. The logbook is 2 and the typed report is 8. Then coursework 2 is you have to type lab report 4, and that's worth 10%. And as I was saying, that's as much as your end of semester 1 exam. So that's a big deal. Okay. So anyways, you have to give me your labs in 2 forms. Coursework 1, which is the book plus 1 report, and coursework 2, which is the second typed report.
So here is 10%.
Yeah.
We should do 3 type the electricity. We can type the handwritten.
No. Only handwritten. I don't want it typed. These.
No. I talk about we can type that one.
Oh, you can choose it.
Yeah, electricity or pension. You can choose the pension.
But don't choose it.
Okay.
Trust me. It's much better for you through the electricity. You must trust me on this. Okay, continue. So, the reason I'm telling you what you need to do for the lab report is that I am told in the syllabus that it's important that students are given the list of what's required, as well as the marking criteria. So I'm going to tell you where the marks go for your work, which is really important. So, I think we know this already. The laboratory logbook can be handwritten. Yeah. No, this is not really a topic. It's not a lesson. We're talking about the requirements for the labs, the reports. So the book is handwritten, and what should be in the book. Now, the good thing is the lab book you use, I actually made it for you, so you have all the sections in it already, which is good. So you have a section for the title. Actually, do you have the logbook with you? Yeah, could you take it out and have a look at it? Do you have yours, Sophie? No. Is that home? Yeah. So if you look at the first lab, you can see there's a section for the title. Yep, there's a section for the results and the comments and everything really. Now, yeah, the next part, the typed report. You should use something like Word. So this is maybe information you want to write down. What's the word count for the typed report? So the word count for the typed report is 1,000 to 1,500. Yeah.
Is this the electricity one?
The electricity one. No, this is the electricity one.
Type work.
Oh, please, I'm so tired. Type lab report for electricity.
Including everything.
No, oh my goodness, oh my goodness, oh my goodness, oh my goodness. Right. So you have, look, you have 4 labs. 1, 2, 3, 4. And this is part of, now I'll make this very clear. This is part of coursework 1, coursework 2, no, coursework 1, coursework 1, coursework 2. And then this is it handwritten? Handwritten. And the answer is yes, 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 no. And then this one, is it typed? And the answer is no, no, yes, yes. Here, there's no word count. You just write in the book. There's no word count. But this and this has a word count. And I'm saying the word count here is try to get 1,000 words at least for this one.
Is that including everything, the conclusion?
Everything for lab number 3.
In total?
In total. Conclusion, introduction, everything.
Is it including the numbers?
Oh, why? I don't. No, it's not really including the numbers, but...
Because in math assignment it's including the numbers, right?
Yeah, but...
And physics a lot of math.
I know, but there's a big difference between the two. In the maths assignment, NCUK don't care. The physics assignment, they do care. So... No, not including the numbers, because the more you write, the better. I'll give you more marks for more work. Okay? What now? What? I know, but the good news is there's very small marks for the English. Maybe only like 5% for your grammar.
That's 5%.
Of your grammar. So even if you get 0 for your grammar, you'll only lose 5. Okay? Okay? Okay. Continue? Yes, continue? Continue?
No.
Oh, no, not continue. Yes.
CW1.
Yes.
Choose one of the
Coursework.
course.
For this,
Just 1, 2, 3. It's choose one of these to do all the.
No,
everything, all of this must be in your logbook. And then you choose one of them to type. I'm telling you which one to choose. Choose this one. Trust me. Okay? Although technically it's your choice, please trust me and choose this one. It'll be the best for you. Okay? Alright. So, 1,000 words plus the calculation and diagrams. So They don't count in the words, as you were asking me.
They don't count.
No. So like it's 1,000 words and calculations, diagrams and references. Yeah, don't count the references in the word count as well. Right, so when you type your report, these are the sections I would like to see in the typed report. I want to see a description of what you are investigating. I want to see a procedure. I want to see results, of course, analysis, discussion and conclusion. So these are the 5 main sections. So I think it's good if you write these A, B, C, D, E down because it'll help you in the writing of the report. Okay. Yes? Yes? Okay.
What is the A meaning?
That's a bit like basically the theory, the definitions, you know, the aim, the kind of, you know, like the introduction. I don't know what you call it in chemistry.
Introduction.
You just, introduction, yeah. Yeah, so you can just do that.
You can use the heading, you can call it heading introduction.
Yeah, now just to be clear, these aren't necessarily the headings. So for example, maybe you would feel better if you wrote introduction here. You know, you don't have to use the exact headings here. Also, I would recommend that you use subheadings. So like for example, here, the procedure actually has 3 different parts. You could have like the procedure and the equipment list, what equipment you need, you know. Then you could have the diagram, and then you could have the instructions. Do you know what I mean? So I would recommend for these to include sub-headings. You know what I mean? Subsections. And checked my battery. Yeah, I'm okay. And you do get marks for your headings. So this is just to help you put sections together. What's the difference between results and analysis?
Results is you explain what you get, and analysis is why it's there like this.
No. So the results would be like, for example, this part, the results, just the data. Whereas the analysis is the calculations you do on the data. Like the graphs and the averages and things like this.
So what about diagram?
Where do you think the diagram goes?
You say it's in the procedure.
Yeah, you can put the diagram. You could put a diagram in the procedure for how to assemble the equipment, how to put it together. But you can also put a diagram in the description to explain the theory. Like for example, I'll give you an example. Like for example, for the pendulum, you could have one diagram that explains the forces. This would go in the section A. And then you could have another diagram in section B which shows how to assemble the equipment. So you could have 2 diagrams as an example. Yeah? Okay. Do you have this slide? Continue. So, coursework 1 is 100 marks, 10%. So 20 marks is for the logbook, like I said. So it's worth 20%. And the overall mark for coursework 1. Now, for the logbook, you can't share your logbook, of course. So, individual logbooks. But that's obvious. Nobody would think about, Andy wouldn't give me Hareen's logbook, pretending it's his, okay? Your own logbook, that's obvious. So, for a good logbook, now I don't even think you need to write this down because again, my logbook has the sections in it. So I want a record of your findings, included repeat observation. Everybody did that. This is why I said to do everything twice, or to have a, L1, L2, V1, V2. This is important. Comment on the procedure. So you have a box for the procedure. And this is what I was saying to you. Was it Hareen or somebody about the conclusion? An important thing about the conclusion is reflection. And that means you say what went wrong and what you could do better next time. Do you understand what I mean? Like how to improve the experiment. So for the conclusion, that's a key thing, the reflection. Yeah? Okay, continue? No, yeah. You finished your chemistry lab report? Or you started it, or?
Waiting for Lauren to give our
Draft?
Yeah.
What was the word count for chemistry?
We don't have one.
No.
No word count?
Yeah.
So you could write 10 words?
Absolutely not.
Okay. Well, what was your word count?
I will check.
Okay.
Because I finished the day before I should submit.
Good idea. What, do you remember your word count? Andy? Sophie? Amanda? No? Okay, fine. Continue. I'm recording this also. It's recorded. The written report or the typed report, that's 80 marks, 80%. And the overall mark for coursework 1. Again, it should be an individual report, no sharing. And the sections you need are, okay. So the next slides are important for the type report for the electricity, coursework 1. So here are the sections you need. So the first section you need, of course, is the introduction and theory. This is 10 marks. Now I'm telling you how many marks you get for each section of your report. I don't think you get this information in maths or chemistry, because I think it's a bad idea. But the syllabus says I must tell you it for physics, so I'm telling you.
Why?
I don't know why. I think it's a bad idea. As a teacher, I don't think it's a good idea for students to know how much each part is worth.
Why?
Because I want you to feel like every part's important, But anyways, that's not my choice. That's someone else's choice, or whatever. Okay, so in this section you should have the title and the aim. The theory should be introduced and references. Okay, so these are the 2 key points here for the introduction. So, make some small notes about this. Title, aim, and reference is the key here. Before we continue, listen. Please don't write everything. It will take so long if you write everything. Just write key points to remember, okay? So here, what do we need? Title and aim. And here, theory and reference. It will take all day if you write everything. And this is recorded. You can watch the video if you want. I'll upload it today. I'll call it Physics Prep 3 because I have the 2 other videos, Prep 1 and Prep 2. Continue. Right, next you need the procedure. So I want to see the equipment. I want you to show that you used it correctly. So, you know what I mean, when you write the procedure, you need to say what to do clearly, and I need to see that you understand how to work the equipment. So if you say, I don't know, I put the voltmeter on my head or something like, well, yeah. I need evidence that you use the machine correctly in the procedure. Oh, and also don't use I or me. Use the, what's it called? Passive impersonal. Don't use I and me. Say like the voltmeter was connected to whatever. The same as chemistry. Yeah. Okay. The diagram should be labeled and clear, so I want good diagrams. The procedure should be clear, and now the procedure is your own words. No copying procedures from the internet. It needs to be your words. Okay, so these are the 4 key points, and the procedure is 15 marks. Continue. Oh, Andy, it looks like you're writing everything. No. Key points.
I just write the key points.
Okay, good. Continue. Yep. Okay. So next, the results. They're 15 marks. Now the key thing here is repeat observations where appropriate. And in the next lesson we'll talk about uncertainty. Well, you actually have a way to calculate uncertainty that I told you about. If you remember, the uncertainty is the difference in the 2 values divided by 2. So if you got 1.1 meter and 1.2 meters, the uncertainty is 0.05 meters. But we'll talk more about that in the next class. Next is correct units. Now I'm going to say that again. A lot of people think they have the right units and they think they use the units everywhere, but a lot of time people forget to have units on everything. So I'll give you an example of what some people forget. So for example here, with this graph, here is length and the unit is meter, and here is time squared and the unit is second squared. So when people are calculating the slope and they would say, the slope here, I don't know, the slope here, whatever, I can't even remember what the number should be, like 4. That's wrong. You need to say the units. So when you calculate the slope, you need to say m equals 4, and what would be the units? No, look, it's y over x. So seconds squared per meter, that's the units. Yeah? So that's what I mean, okay? Don't forget your units. Everywhere there is a result, you must have the unit with it. Okay, next point, measurement should be taken over an appropriate range. You've already done that. So for example, with the pendulum, what do you start with? You start with 1 meter, and where do you finish? 0.1. So you've done that already, that's fine. Okay, so that's it for the results. Next. Does anybody watch Flash?
What a gosh?
Flash?
No.
No.
Why?
I watched it last night.
What is it?
Oh, I slept at 1:30.
Because of that?
No, I'm watching other shows. I know, I'm terrible. But the problem is, I don't get home until late because I have private classes. So then I don't want to go to bed, I want to watch TV. Okay, continue. So now is the analysis, and this is worth 20 marks. You know, it's the same in China and Korea. Maths teachers have very busy private classes.
No, my high school teacher travel every week.
For private classes? Yeah. Me too. Maths teachers are very popular. Okay, the analysis. So, data, you should use software to make the graph. Now, actually, we'll have a class next week on using Excel for your lab report. So, if you try to remember on Monday to bring your laptop. Sohi, if you want, you can share maybe with somebody if the laptop's too heavy for your back. What?
No.
I'm caring. Why is it funny that I care? I care. No. So if you can bring your laptop for next week, we can look at how to use the Excel. But I'll talk about this next week, the graphs.
You will teach us.
I'll show you how to use the Excel to write the reports. The thing you need to do first is the handwritten logbook. So this is the first thing for you to do. Yeah. Then once that's finished, you can start typing the reports. Okay, next point. Of course, the graph should be titled with correct axes and scale. Now this should be no problem to you because you make graphs for maths and for chemistry, so it should be no problem. You know your graph needs a title, right? And an X and a Y. Who was your maths teacher? Your maths teacher now is John. And last time? And before that? Me. So you had all three. So you could, yeah. You had a little bit of everybody.
So
Okay.
I have teacher because change the teacher.
Change the teacher? Yeah, it's good.
No.
Get tired of looking at one teacher.
No,
Get a new teacher.
No.
No?
Compare teachers now.
Yes. Okay. Next. Points should be plotted accurately. Now look, if you're using Excel to do this, you don't have to worry. Excel will do it correctly. Best fit line, we'll talk about that next week. It's the line on the graph. The slope, this is slope, should be calculated using a large triangle or least squares fit. Again, we'll talk about using Excel to do this next week.
What is best fit line?
Best fit line is something that is done in Excel. So what it is, here, if you have your graph and your data is like this line here is called the best fit line. And we will learn how to make this in Excel. Excel can do this automatically. Did you have to do anything like this in chemistry?
No.
No.
What graphs did you have in chemistry then?
No graph.
Wait, what? No graphs?
You did the titration experiment.
No graphs? Zero graphs?
Zero.
That's disgraceful. Well, you make graphs in maths anyways. Okay, next is you should use the slope correctly. So for example, in the Ohm's law experiment, do you remember, not Ohm's law, the electricity experiment, do you remember what the slope represents? 1 over R, yeah. Data should be displayed correctly. So what's a good way to display your data? Well, in a table, right? Is that what you did in chemistry? Did you at least have a table?
Yeah.
Okay, good. Relevant physics principles should be discussed. So in other words, talk about in the analysis any related physics formulas or ideas. Yeah?
No.
No. Okay, next point. I feel like you're writing everything. Are you writing everything, Amanda Grace?
No.
Are you sure?
Yes.
Okay.
Relevant physics principle.
This, Grace, this means you should talk about any formulas you might need to use in the analysis. Calculating should be carried out correctly, and you should check if you made mistakes. What happened to your hand, Andy?
Sure. I don't know what sport is so hard.
Oh, okay.
Yeah.
You didn't get in a fight then. Okay, next. Uncertainty should be calculated. Uncertainties?
Delta.
The delta? Yeah, I'll show you how to calculate those in the next class as well. But I think with Lorraine you did some uncertainty calculations, didn't you? Yeah. A lot, good, okay. See, this is the great thing for me that you do chemistry, because Lorraine does a lot of lab preparation with you, which means I can do less. Continue? Right, so now the discussion, which is 10 marks. Valid conclusion. Realistic improvement, so how to improve it. And they're the two key things I want to see in the discussion. Okay. Continue? Yeah? Okay. You get 10 marks for the style. So the style is, you know, the headings and the subheadings I was saying earlier. Grace, this part is for you. The grammar, that's included in the 10 marks. Good academic writing. So this is like using the past passive. And your reference, you should use Harvard, which is what you learned in EAP, right? Yeah.
You think we should also write a test?
Past passive is good academic style. And you know, for me, I think it's very important that you never say I or me in my report. So you never say I did this.
Or can you?
Give me an example.
When you calculate something.
Oh yeah, you could say like when you calculate this. Yeah. But actually, Grace, let me show you how to make it more academic. So, you mean if you say something like, when you calculate slope, you need to blah blah blah. You mean something like this. I think it's better if you change it to when calculating slope, take care to, you know, try not to use a pronoun. But if you really want to use a pronoun, use this pronoun. Do you know this pronoun? Have you heard of this pronoun? One. It's also a number, but it's also actually a pronoun. So you would use it like this. When one calculates, you know this?
Yeah. Maybe.
So what I'm saying is, if you really want to use a pronoun, you should replace you with one. It's academic. It's more formal. I don't know if you have you seen this as a pronoun before?
Yeah.
Yeah?
In the reading.
And the reading.
Yeah.
Yeah. So try not to use you. But if you must use a pronoun, you can use one. Don't use it too much. Okay. Oh, sorry. Did you want to write that down?
Go back to the slide.
Back to the slide.
Or we can say the slope was calculated by.
Yeah, that's all fine. Yeah. Not using pronouns makes your report automatically sound more academic, just by not using pronouns. Some physics teachers feel that you should use pronouns and personal, but most feel that you shouldn't use pronouns and it should be impersonal. And I understand why people say both reasons. But all you have to care about is what they want in Manchester. Okay, continue. Next. what you need to do to get high marks. You all want high marks, I know. So for the logbook, for high marks, you need an excellent record of findings and results. So, in other words, make it clear, easy to read, don't have a mess.
How easy?
I need to look at it and go, that's very clear. This is the length, this is the time, this is the time squared. Yeah. Now, I think next week also we can have some time where you work on your lab report in class. I can check it for you, make sure you're doing it okay. Yeah. Include repeat observations. So again, this is like L1, L2, V1, V2, U1, U2, V1, V2. The procedure. Good, excellent comment on the procedure. So make the procedure very clear. Again, clear comments on useful techniques. So this is like, clear instructions on how to use the machines, how to make the measurements. Repeat observations like L1, L2, V1, V2.
When you include the techniques in the procedure?
Well, you could put the techniques in the procedure. That's the only really place it can fit in your book. It just really means, again, it's the same point. Have a good, clear procedure, including any things, an example would be with the Snell's law. So a good comment about the Snell's law would be, place the light box on a flat, stable, not moving table, stationary table. This is what I mean by good, clear, useful comments. Yeah. Reflection. What did I mean by reflection? What was reflection earlier? Well, reflection is where you say what went right, what went wrong, and what you should do next time to make it better. Yeah? So by reflections, again, I mean for future work, how to improve it. So do you remember anything from the experiments that you feel went badly that you could change for next time?
Yes.
What?
The voltmeter.
The voltmeter. Excellent, excellent. So you could say, now this is a good example. The battery was running low on the voltmeter. Do you remember? So you could say, in future,
I have to check the voltmeter to see if it's good.
Not only that, but in future you could say, make sure you bring a spare battery for the voltmeter. As the voltmeter battery was low, it caused some trouble in measuring the voltage. This is all good. This is real life. Do you remember any problems you had with the experiment?
A longer card.
Yeah, so you feel like a longer table?
Yeah, a longer card design.
Okay, good. So this is what I mean by reflection. How to improve it next time. Yeah, okay, good. Right, now for some reason I have this slide twice. I need to delete that. Okay, for the report that you have to type, what do you need for high marks? This is easy. 3 references in the theory. I want 3 references at least. So excellent, title and aim, theory with 3 or more references. Yep. Got that? How many references do you need for chemistry? How many did you use? Amanda, do you remember how many? No?
I use 4.
You have 4, okay. Many, okay. 3 is what I want at least for physics. I don't need more than 3. 3 is enough. But maybe you want to give me 4 or 5 in case one of them is bad.
Bad?
Yeah, don't give me bad references.
But just like in the introduction, maybe we need 2 reference, and in the discuss and the conclusion, maybe we need more.
Okay. In fact, for the physics, they only care about really the reference in the introduction and the theory, and they want 3. If you want to include more references in the discussion, that's fine. But for high marks, they just care about having 3 in the theory and introduction. Yeah? Okay.
Wait,
Yeah?
by 3 correctly cited references is like for the end, the part, right? The references, the bibliography.
Yeah. You need to have 3 citations in your theory
You
section.
have to have in-text references in everything other than the introduction.
No, it's weird that for the syllabus they seem to only care about having it in the introduction and theory. Now, you are welcome to include it elsewhere, but as far as your marks are concerned, it matters more about it being in the introduction. Okay, next point. Excellent discussion and conclusion. And again, I said it already and I'm saying it again, excellent suggestions to improve the experiment next time. Okay, next point, excellent structure. Sometimes students lose marks because they don't have clear section and subsection. And I'm sorry, for excellent, please no grammar or spelling mistakes. Or maybe I should say, not many grammar or spelling mistakes. Okay, next. Good academic style. But you know this because you have done a report for Lorraine and for Roland and me, and soon Joan. References should be used Harvard style. This is what you learn. This is what you use for chemistry, yeah. Now, the next point. I know you use. Focus, Andy. Focus. I know you use the equipment correctly because I was there. You know, I saw you using the equipment and you used it correctly. However, the person reading the report needs to see evidence you used the equipment correctly. Now, what would be some ways to show evidence that you used the equipment correctly?
Diagram.
Having the right diagram. What else? Having the right procedure. Having the right results. So, for example, if you used milliamps, then saying, you know, the ammeter was set to milliamps. You know, excellent diagrams as well. Excellent description in students' own words, of course. Please don't copy stuff from the internet. It will not get you extra marks, it will get you less marks.
Wait, you can't get the diagram from the internet?
No.
That's a draw.
Yes.
Like, can you show you can take a diagram?
Do I look like Lorraine? I definitely don't look like Lorraine. It could not be more different, okay? This is physics. I'll say it again. I want nothing from the internet. I want your diagram, your words, your pictures, your drawings, no diagrams from the internet.
Did you see the email I sent you? Did you see my diagram?
I've not had time to look at it. Is it great?
I don't know, but I think it looks colorful.
Okay, good. Right, do you understand? It's not like chemistry. I want your beautiful pictures and diagrams. Results and repeated observations again. Uncertainty calculation, correct units, measurement over appropriate range. And lastly, excellent use of software. So I'll teach you how to use Excel next week. Should be no problem to you. Yeah? Continue? Okay. Now, I have you for ICT on Friday. Did you get the email from Lorraine about the software you can use? Yeah, did you do it? No. There are two programs you can use for your maths and physics reports. You can use Excel, that's fine. But the program I want to teach you on Friday, it's more common program at university. So maybe you want to think about using this new program because it's what you will have to use at university. It's more academic than Microsoft. Microsoft is more general for everybody, whereas the program I want to show you on Friday is more of an academic program. It's also free. It's on Windows, Apple, and Linux, so everybody can use it. Yeah? Okay. Continue. Excellent discussion of the physics, of course. Right. Excellent graphs, of course. Beautiful graphs. Come on. Oh, there's stuff underneath that's cut off. I better show it to you. This is written twice? No. Which slide am I on? Assessment criteria for the report. Assessment criteria for the report. Assessment criteria for the report. Here. Okay, so which was our last one? Graph is correctly titled. So there's a little bit that just got cut off the bottom of the screen. Use the Excel program, that's fine. Check for errors, that's fine. And calculate the uncertainties, that's fine. And then the very last point, which is off the screen, is conclusion is correct. Correct conclusion. Okay. So I need to make this a bit smaller. Alright, we'll continue anyways. Right, so now coursework 2. So this is the big report for experiment number 4. Which experiment is number 4? Newton. How much is that worth?
A lot.
Which how much?
1,000.
10%.
10%. 1,000% would be nice, but it's only worth 10%. Yeah. So for this report, only use Word. Don't use, well, I suppose you could use something else, but Word would be best if you want to use it. Example, Microsoft Word. So word count. Now, although it's the same, for the electricity experiment, I'm happy if you're closer to 1,000, but for the last experiment, since it's worth 10%, please try to be close to 1,500, please. Okay. So this report, introduction and theory, procedure, results, analysis, discussion. So basically the same as the electricity. However, I will say for this experiment report, I want a bigger introduction and theory than in the ohms one, the electricity one. So can you make a little note that this part needs to be bigger, the part A? Should be bigger than the last report. Okay, continue. Yeah. Now, do you remember that I asked you to send me on the plan for the experiment 4? Now, I know some people emailed me. I never actually looked at it yet. You emailed me the plan. You emailed me the plan. Somebody, did you email me the plan? Yeah, did you email me?
Oh, yeah.
Oh, Grace.
I finished
Amanda?
it.
Okay, fine. So that plan you include it in your report, and it's worth 10% of the report. So the plan, you need to list all the equipment. I didn't look at yours, Andy or Hareen, but did you do that in your report plan? Did you list all the equipment?
Yeah.
Yeah, good. And then did you show how to use, say how to use the equipment, like how to set it up, where to put it?
I draw a diagram and then.
Yeah, okay.
It doesn't have to label the diagram.
Yeah. Wait, did you not label it? You need to fix that. Now this is maybe what you've not done yet. You can add it in. Justify. What does that word mean? Justify.
To like strengthen
Mm,
the point,
yeah, give me something else though.
to give reasons.
Yeah, give reasons why you used the equipment you used. Now, the real reason you used the equipment you used is because that is the only equipment I had. But you need to pretend that you had a choice. You know what I mean? I'll give you an example, okay? When you're ready.
We will have a long time to finish.
I haven't decided how much time. Do you have a holiday soon?
No.
Are you sure?
No.
I thought you had like
We have.
3-day weekend in June.
We have the assignment.
Yeah, I see. I want to wait until maybe you don't have your chemistry to do. Then you can give me the physics. Anyway, for this point, for example, how did you measure the mass of the trolley? The spring balance. Why did you pick the spring balance? Well, that's the only thing your teacher had. But you can't say that. You need to pretend like you chose it. So, if we're pretending you chose it, what would be a reason for choosing it? What do you think?
It is reliable.
Give me something else.
No electronic balance.
It is cheaper than electronic.
Correct! This is fine. So, one reason the spring balance is used is because it's a very cheap way to measure the mass. I mean, this is a good reason, you know.
It is easy, but easy to put it and put it.
It's easy to use. Also, what is the maximum mass on the spring balance? Do you remember its limit?
1,000 grams.
1,000 grams. And the trolley is 600 grams. So actually it's a very suitable size because, 600 grams is in the middle. So, the scale is quite appropriate. Why did you use the photo gates to measure the speed?
Accurate.
Well, firstly, why did you use 2 photo gates? You got a U and a V. Correct, yeah? And why use photo gates? Why not use something else?
Okay. Good machine.
Well, it is a good machine. It's very accurate. It's very accurate, and also they're actually not too expensive. Maybe €50 each.
Is that not expensive?
You must believe me when I say I looked for the cheapest option, and this was the cheapest option. Well, no, sorry, that's not true actually. That's the second cheapest option. The cheapest option I felt was too old-fashioned.
Oh, okay.
I don't know if you ever use a ticker tape timer.
Oh, yeah.
It's too old-fashioned, never mind.
This one.
Oh no, that would be even worse. Alright, next in the plan, again, you need to you need to say it's important to repeat the measurements. So this is why you did everything twice. So you need to say this in your plan as well. It's important in the plan that you say about repeating the measurements. Twice would be great. Yeah? Continue? Yes? Okay. Now, the next point is how to control other quantities. So there are other things that affect the experiment. What would be other things that might affect the experiment that might cause a problem?
A random error.
Yeah, but give me an example.
The spring balance doesn't work properly.
Yeah, but give me something that something else, not to do with the equipment really.
The table is not so.
The table is not smooth. Yeah. So yes.
Not horizontal.
Not horizontal. Yeah. So at this point means you should make reference to things that could cause a problem. Like for example, you should say the trolley should be put on a smooth horizontal table, as an example.
Do we have to explain what random error and
This is,
other error?
we'll get to that in time as well. Okay, continue. Yeah. what is the state, what is independent, and what is the dependent? Have you used this word in chemistry, independent and dependent? No. Independent is what you change, and dependent is what you measure. So, for example, in the Newton experiment, what did you change each time?
Weight.
Yeah, the force.
Force.
And what did you measure each time? The acceleration. So, in other words, the independent is what goes here, look, and the dependent is what goes here. Independent, dependent. You haven't used this vocabulary with Lorraine, have you? No, okay. Oh, you have? I see now, Hareen wasn't listening to her. He was thinking about other things. Okay, continue. Draw the diagram. You said you have a colourful diagram, but is it labelled?
No.
Then it's a bad diagram. And you do get marks for commenting on the safety. So what's the safety with the trolley experiment?
Don't put the hand.
Don't put your head under the fallen weights, or maybe more serious would be, don't have your hand on the table when the trolley is moving.
Don't put the trolley onto the other people's face.
Yes, yeah. Don't swallow the weights. Don't put the string around your neck. Yes. All these things.
How to spell accurate?
How to spell what?
Accurate?
What word?
Yeah.
What does it mean?
Something about the photo date. Accurate? Any something.
Accuracy?
No.
Acceleration?
No. A word to explain how to this photo date.
Accurate.
Yes, how to spell.
Let me write it down for you. Where do you want it?
Here.
Accurate.
18.
Yep. Okay. And then also in your plan, how the data will be used and collected. So I'm sure you probably have more you need to include in your plan. Yeah. Okay. Continue. Yeah. And then 2 more points. What is the main cause of the error? So I think the main cause of the error in the Newton one is, well, I won't tell you actually, you think about it. What's the main cause of the error? And then the last point is that it's well organized. Yeah? Okay. Huh? Is well organized with correct actions, correct order. So, for example, the conclusion is at the end and not the start. The procedure is at the start, not the end. Yes? Okay. Next now. So that's 10% for the plan. Now the introduction and theory, wait. You don't need to write this down because I think it's the same as the last report. The title and the aim, the references, and so on. So that's the same. The procedure, again, it's the same points. It's 15 marks for the procedure. The equipment is correctly assembled, operate effectively, diagrams labelled and clear. So that's the same. The procedure should be in your own words. So this is all the same as the other typed report. The results, again, repeat observations, correct units, appropriate range. The analysis is 30 marks. Now I think that's more than the last one. For the last one, was it 20 marks for the analysis? Yeah, so this is a difference. It's 30 marks. But it's all the same points. The same points as the other one. And the discussion is 10 marks again, it's the same points. Valid conclusion and realistic improvements. So again, the same points. Now, the style is also worth 10 marks. Again, headings and subheadings. Again, no grammar or spelling errors. Good academic style. So this is all the same. And references in the Harvard style. For high marks, now the only thing that's different, everything else is the same. You can see, 3 references and all that. But the only thing that's different is for the Newton experiment, you need to include the plan. So the plan, you get marks for excellent reasons why you use the equipment. Now look, again, we all know the real reason. That's the only equipment I had. But you need to pretend that you went to the physics lab and you picked this out and said, yes, I'll use this and I'll use this. Excellent evidence of techniques, how to use the equipment. Excellent label diagram. And also what's important is excellent understanding of maybe some of the errors, the reason for some of the errors. This is all in the plan. And lastly in the plan is the safety concerns. Yes? Let me just double check. And let me just double check, but I think all the other points are the same. Title and name, theory, 3 references. Okay, that's the same. That's the same. That's the same. Yeah, all the other points are the same. Something else to show you. I know you're very tired, but more things to show you. So let me just close this.
How much more?
A little more. I won't tell you. It's a surprise.
No.
Now, one of my slides I repeated twice. Do you remember which one? The log, the written, the equipment, observations, data, valid, the report, an excellent, list of equipment, title, observations, data. Okay, let's have a look here at the second thing. What's wrong? Well?
I don't know.
She? What?
Yeah. I teach you before, you forget.
What?
Yeah,
Super Saiyan?
No.
No? Okay.
In Kung Fu Panda.
Ah, Kung Fu Panda.
No, you didn't remember.
Now I remember. Okay. So now we'll just talk a little bit about uncertainty. Now all I want, this lesson isn't really about calculation, this is more about vocabulary of uncertainty. Before you write anything, this is the most important thing I'm going to tell you about any physics lab report. Now listen, come on, up.
I'm tired.
No, come on, be strong, okay? If you only remember one thing about writing lab reports, I want you to remember this. If you only remember one thing in your life, please remember this. In physics lab reports, it's very important whenever you make a prediction about a value, like the value of G, the value of resistance, whatever, that you always include an error, how much you could be wrong. So for example, if you have an experiment to calculate G, and you say G is 9.8 meters per second squared, it's very important that you include some kind of what's called bounds or range of possible values, like 0.1 meters per second squared. If you only remember one thing in physics lab reports, remember this: the importance of having boundaries on your predictions. That's so important. In fact, I cannot tell you how important it is. So if you don't have this, then your result is useless. If you don't have this, it's useless then. So for a result to have meaning, you must not just have the measurement, you must also have how accurate it is. Okay, this is maybe a little bit too much here. So anyways, this is called the uncertainty, and the symbol we use would be delta. So for example, this is G, and this here would be delta G, as an example. So this is called the uncertainty, how uncertain you are.
I have a question.
Yeah.
We can like put the error in like.
We actually have to calculate it.
When you calculate,
Yeah.
you have to put the error in there.
Yeah, I'll show you how to calculate this next time. I'll show you how to calculate it, yeah. Okay. So I just want to give you some definitions. So true value. I think maybe you call this in chemistry literature value? Yeah. So true value, you cannot actually know it. It's impossible to know it. But in practice, an accepted value is used. And this accepted value is usually, I think, called the literature value. This value is what's found published in... yeah, so I guess there's a small difference. You understand that you have the literature value? So what did you use in chemistry that was the literature value?
0.05.
Yeah, but what was it measuring?
The molarity of HCl.
A molarity of something. Yeah. So you understand that literature value, that's not really the true value. They should be really close. Yeah. And most people think the literature value and the true value are the same. And they really are the same, but you understand that they're not quite the same, that maybe there's a very small difference between the two. So in fact we can never know the true value. Unless, I don't know, you're God or something. But you are not. So you cannot know the true value. But you can know the literature value or the reference value. But the true value is not the reference value. But for me, they're practically the same. So that's true value. Okay, I don't want to talk too much about that. Right, so since the true value cannot be known, in practice, a reference value is used. This reference value is usually done by many experiments. The value is not the reference value. Wait, is it the same thing? Oh my goodness, that's the same thing. Sorry, I had that twice. Let's forget about that. Right, okay, so definitions now. Have you done this word with Lorraine? Accuracy. Maybe, okay. So I'll draw a picture for you. Oops. So you understand that you have a true value, and then you have your value. So for example, maybe the true value is 9.81 meters per second squared, and your value is 9.8 meters per second squared. The accuracy is how far away you are. So, you know, if you're here, this is more accurate. You are closer to the true value. So accuracy is how far away you are from the true value. This is what we mean when we say accuracy. So I would like you to write that definition down. Accuracy is the closeness between your measured value and the true value.